Hi, welcome to your Algebra 2 lesson on section 3.7. We are going to talk about determinants of matrices and something called Cramer's rule. We're also going to learn to take the area of a triangle using determinants, and so we've got lots to do today. So the main objectives are for you to be able to evaluate determinants of matrices and apply Cramer's rule, and you'll also, like I said, use the determinants to figure out the area of a triangle. Okay, the determinant of a matrix, the formula for that depends on the size of a matrix. We only have them for square matrices, so we're only going to learn two of the formulas. Now, you're not going to have to memorize them. Like I said, I will have you memorize things that need to be part of your common body of knowledge that you need to take with you. For things that are just kind of specific to this course, I'll provide you a formula sheet. So for your test, you'll have the determinant of a 2x2 matrix and the determinant of a 3x3 matrix given to you. But you do need to be able to use them. So if you'll notice, the determinant of matrix A, B, C, D can be written in much the same form as the matrix. It's just instead of the brackets, you just have almost like absolute value bars around the elements. And so you have that notation, and it is equal to AD minus CB. So if you go along the main diagonal, you multiply and then minus, and then you have the product of the elements on the minor diagonal. Now, for a 3x3, you're going to have to actually extend what you see in the matrix. So we've got determinant of A, B, C, D, E, F, G, H, I. And so you put those elements in just the straight bars there, and then you copy the first two columns again. So if you notice, I have to the right of this second bar there, I've got A, D, G as a column, and then B, E, H. And then it's real easy to do. You go along and you start with the first main diagonal, and so A times E times I, and then plus, and then you go over 1 to B times F times G, and then you go over, and then plus, and you go over to the third main diagonal there, C, D, H. So that's why you have to extend it with the two extra columns. And then you do minus, and then you go along and do the minors. You do GEC plus HFA plus LDB. Oh, excuse me, IDB. IDB. Okay, so remember when you're subtracting that sum, you're going to add all those up together and then subtract. And again, this is one of those things that's a lot easier actually to execute and do than just seeing it with no numbers involved at all. So let's look at an example of a 2x2 and an example of a 3x3. Okay, we're going to evaluate the determinant of the matrix. So for part A, we have a 2x2. For part B, we have a 3x3. Okay, so for A, you just use the determinant symbol, and you've got 5, 4, 3, 1. You multiply across the main diagonal, so 5 times 1, and then minus the product along the minor diagonal, 3 times 4. So 5 minus 12 is negative 7. Okay, now we're going to do a 3x3. So we copy what's inside the matrix, inside just lines there, and then we recopy the first two columns immediately to the right. And so then we go through, and our first set of parentheses, we put the products along the main diagonals all added together. So 2 times 1 times negative 2 is negative 4, and then plus negative 1 times 0 times 3, well, that has a product of 0, and then plus negative 3 times 4 times negative 4, that's negative 12 times negative 4, so positive 48. And then we do minus, and then we do our second set of parentheses, and we come back across the minor diagonals. So 3 times 1 times negative 3 is negative 9, plus negative 4 times 0 times 2 is 0, plus, and then negative 2 times 4 times negative 1 is positive 8. Okay, so now let's simplify inside our parentheses. We've got negative 4 plus 0 plus 48, that's 44. And then minus negative 9 plus 0 plus 8 is negative 1. 44 minus negative 1 is the same thing as 44 plus 1, and so we get 45. Okay, now all of this is well and good, but if there's not some sort of application for doing the determinant, it seems kind of weird that we would even care. I mean, why find this out? One of the applications for the 3x3 determinant is area of a triangle. Okay, we can actually use the determinant for the area of a triangle, and you will be given this formula on your test as well. The area of a triangle with vertices x1, y1, x2, y2, and x3, y3 is given by plus or minus 1/2 times x1, y1, 1, x2, y2, 1, x3, y3, 1, where the symbol plus or minus indicates the appropriate value should be chosen to yield a positive value. Area has to be positive, so if the determinant turns out to be negative, then we multiply by negative 1/2. If it turns out to be positive, we multiply by positive 1/2 so that our area is positive. Okay, so let's look at an example of this, and then that will be it for video 1, and we'll move on to video 2. Okay, so let's advance. Okay. Off the coast of California lies a triangular region of the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting Bodega Bay, the Farallon Islands, and Año Nuevo Island, as shown. In the map, the coordinates are measured in miles. I just wrote in the coordinates on the problem on your notes because I didn't really have a way to copy the map. Use the determinant to estimate the area of the region. Okay, so let's consider point 1 to be negative 1, 41. So x1 is negative 1, y1 is 41. x2 is 38, y2 is negative 42, so that's our second point. And then we'll use 0, 0 as our third point, so we'll use x3 equals 0, y3 equals 0. So then we'll just plug into our formula. So the area is going to equal either plus or minus 1/2, whatever we need it to be so that the product is positive, times the determinant of negative 1, 41, 1, 38, negative 43, 1, and 0, 0, 1. Okay, so we need to recopy those first two columns in order to be able to calculate the determinant. So we're going to have plus or minus 1/2. We're going to multiply down the main diagonal, the first main diagonal. So negative 1 times negative 43 is 43 times 1 is 43. And then we move to the next main diagonal. So 41 times 1 times 0 is 0 plus. And then the final main diagonal, 1 times 38 times 0 is 0. And then we're going to do minus, and we'll go back and get our minor diagonals. So 0 times negative 43 times 1 is 0. Plus 0 times 1 times negative 1 is 0, plus 1 times 38 times 41 is 38 times 41, which is 1,558. All right, so we get 43 minus 1,558, and that gives us negative 1,515. So we multiply by negative 1/2. So that we get positive 757.5. If we'd had a positive value for our determinant, then we would have multiplied by positive 1/2. But approximately 758 square miles is the area of the region. So that's pretty cool. That gives us a way to calculate the area of a region using the 2x2 matrices. Now, in a minute, when you come back for video 2, we'll talk about Cramer's rule for a 2x2 system. There is Cramer's rule for a 3x3 system, but we're going to leave that for another course some other time. We are going to learn how to solve systems of equations using 2x2 determinants in Cramer's rule for a 2x2 system. So come back for the next video and you will learn how to do that.